So good afternoon, everybody. Thank you very much for joining us today for how to set up disaster recovery. My name's James. I'm here from Data Barracks here in southwest London on this beautiful day, and I'll be running the session. So without further ado, let's kick off. And I'm going to start with a very quick run through of the agenda, some housekeeping for the session. So we are scheduled today for this webinar to last 30 minutes. If you have attended any of our webinars in the past, you'll know we're super hot on timekeeping. I think it's always terrific that you take the time out of your day to sit on these sessions. And I know for myself personally, I always like them to be short and sharp and not go on for a long time after the scheduled time. So we'll be really tight to that. To answer the first question that we usually have, slides will be made available after this session. So either later this afternoon or perhaps early tomorrow, we'll send out the slides for the session along with the links to any of the resources, and we will also be recording the session, so don't feel you need to scribble anything down. You can get to this later on. And then lastly, we're using GoToWebinar. If you used it before, you know the question and answer section is on the right hand side. If you have any questions, do put them in. Again, so because we're really hot on timekeeping, sometimes what does happen is we don't have time to get through all of the questions, but I can promise we always make sure we go through and answer every question that we're that you pop in. So anything that does crop up, you know, just pop that in there. So if we can answer it on the session today, we'll do so. If not, I'll either email and respond to you personally, or sometimes when we've got lots of really good questions that we don't have time for, we'll publish answers to all of them on the blog and include that link. So housekeeping out of the way, right? So the agenda for today. So I'll start off by putting this in a bit of context. So there are 3 stages to disaster recovery. There's the setup stage, which is what we're talking about today. There's the business as usual, so keeping everything working perfectly in peacetime so that it's there should you need it. And then obviously you've got the invocation. Now we're focusing just on the first of the 3 today. We may hold some future sessions on the others. If that's of interest, then then obviously drop us a line, and perhaps we'll do that later in the summer. And each of those 3 sections, there's broadly two subsections to them. You've got the operational aspects to the setup, and you've got the technical aspects. So we're going to be talking about operationally how you put this all together, what the aims and objectives are, where this fits together with a broader business continuity strategy, how you hold an initial workshop and kickoff, and then really we're going to be focusing mostly today on the technical aspects. So doing the installation, considerations for bandwidth, testing and exercising, user acceptance testing, etc. And really what I want us to go through today is a lot of the considerations and the gotchas of when you're doing this. What are the things that you need to be thinking about? So I'll start with the operational setup, and I guess also broadly to put this all in context. This is a slide that we threw together for another webinar that we held. That one was on how to write a business continuity plan, much more around the broader operational aspects of continuity, and then obviously disaster recovery and how that fits as part of it. And there's a number of sections here. We've got 9 sections, and they all fit into a handful of kind of subcategories. So you've got the planning aspects, which take on those first 5 sections. We've then got the enacting, and then we've got the testing and maintaining. Now, I won't run through this in detail, so go and take a look. We have a recording of that webinar if that's of interest. But at the top end, you have what should really be done by either the business continuity management team or the senior management of a business, where you're deciding what you want the scope of your continuity program to be. You're selecting the team and who's responsible for it. You're then performing your business impact analysis and your risk assessments. And at this point, you're then working out how your IT ties into those services and supports it. So basically sections 1 to 4 here, all of this is the planning aspect that should be going on before you start setting up your disaster recovery. Really what we're talking about today is that really relatively narrow section, sort of 5.8, which is putting the mitigation strategies in place. You're putting in your capability to be able to recover IT. Now, in an ideal world, all of this planning will have gone on ahead of time. You as the IT team will have been given a set of recovery objectives for the systems. It'll be really clear. You'll be provided with a budget that allows you to do that. But realistically, it tends not to happen that way. Very often, I think what will happen is you'll have an IT team starting at this point and then needing to work backwards, you'll need to go out and evaluate the market to find out what reasonably you can afford to be able to deliver a particular recovery time. So what I want to do today is not talk about this ideal setup, but actually look at the real world, slightly flawed method of implementing, because it's not the perfect way to do it, but there's no reason you can't get a really positive outcome out the back end of it, even if you're doing this in a slightly more compromised and kind of real world implementation. So with that being said, you may not have a really perfectly defined set of recovery objectives that you'll need to work to, but you'll always at this point be kicking off a project with a broad objective that you're trying to achieve. What I should say here, in fact, is what I guess the place that I'm kicking off this setup from here is where we personally run a project from. So when we kick off a project at this point, we've obviously signed a contract with the customer. So we're not starting from scratch. We've had kind of a great deal of sales and pre-sales engagement. We've made recommendations about a particular technology. We've gone through a process of kind of working out right sizing and pricing. So we're not kicking off at a point of complete ignorance. And usually, so at this point, you've got a broad objective that you're trying to achieve, and I think we can boil this down to a handful of kind of key objectives here. Either you're looking to reduce downtime. So potentially you're shifting to a disaster recovery solution from a backup method where you had a recovery point objective of last night's backup, so 24 hours, and a recovery time objective of potentially 2 days to recover all of your systems, and you want to be back in an hour or a couple of hours. You have a secondary data center that is being closed down. Perhaps you're losing a site, so you need to have a new solution in place. You are looking for, and this is a broad one, to reduce cost, and that could be for any number of reasons. It could be to decommission a data center. It could be to move to a different technology that allows you to reduce that cost, or you're looking to improve your overall capability through outsourcing to a service provider. Perhaps you've got a relatively small IT team. You're worried that if some people aren't around, you wouldn't have the expertise to kind of manage that recovery. So the reason I wanted to sort of highlight these, and I guess we're spending a bit of time before we get into the technical aspects, is when we're doing one of these real world implementations, there's often a lot of compromise and there's some back and forth, and by and large that's all absolutely okay, but obviously you want to make sure that you're not veering away from the singular objective of what you're broadly trying to achieve. So the first thing that we will do when we start a project is we'll have a discovery workshop. So if you're doing this internally, perhaps you're not doing this with a service provider, it's between two of your own sites, you might not call it a discovery workshop. This might be your kind of project kickoff. And the Gantt chart that I've thrown up here, it's not from a specific customer, but it is indicative. So the total duration on this for us as a project is, we're talking about 77 days, and we've got some really long sections on production build and testing and training. And what I will say here is I think we're incredibly guilty in the IT industry as a whole, but often with disaster recovery companies of really over-promising on the speed of some of the setups. There'll be talk of 10-minute installation and have the software working in an hour, or 2-click recovery. And while that's it's true for some very narrow aspects of the software, a full working disaster recovery solution obviously takes a good deal longer than that. So at this point, as I said, you're kicking off the project. Whether you're doing this with a service provider who's like ourselves would be running a workshop, or you've already done it, you've evaluated the market, you've picked your solution. You've spent some time on this, but you've not spent the detail needed to really write out that project plan. So that's what we do here at this point. We're going to look into any assumptions that have been made, review all of the systems that are going to be replicated, look at all of the dependencies between those systems, and at this point we usually find a couple of things that do need to change. So the first thing would be, very often there'll be some more systems that you might want to add, and this is why I mentioned those objectives earlier. If you're looking to reduce cost, So say, for instance, we're talking here about you have 100 workloads, and you've isolated 50 of them as being the key critical workloads that you want to replicate. Now, usually when you work through in detail, sometimes you'll uncover a dependency on a particular system that needs to be included, so you need to factor in a couple of additional machines. Normally, it's not an enormous impact on cost. There'll be some licensing, or there'll be some charges from a service provider, but it does have an impact at this point. So it's an important one to be considering, because usually, as I said, it's not a vast number of new systems to add. But what can be kind of a difficulty at this point is if, for instance, one of those systems and one of those dependencies that you uncover is on a legacy operating system. It's something that hadn't really been factored into that kind of initial evaluation of the market. And sometimes the problem that you get at this point is that it's a system that isn't compatible with the technology or the target destination that you're using for replication. And at that point, I guess we've seen examples of both, where we're able to find some workarounds to make that work, or you need to kind of go back to square one and relook at a solution that will work for all of it. So at this point, we're working through all of the detail. We're assigning resource. We're really getting into the kind of the nuts and bolts of it, because what you want to produce, and it doesn't have to be a detailed project plan and Gantt chart as we would do here, but you need to have a plan of how you're going to get to the end point, which is business as usual, making it work. So you're defining all of your specific activities, you're looking at your timelines, and as the guys here who run the projects are really hot on saying, obviously it's working through your people issues. It's making sure you've got resource availability when you need it. I think now is a pretty appropriate time for this. It's the summer holidays, and making sure that the key people that you need at the key times are available for you to be able to do that. So that's the operational aspect taken care of. Then you move through to the technical setup, and the first part of all of this is installing the software. Now, I mentioned that obviously we're doing this not purely for exactly how we do this. I'm talking through our process, but I want this to be useful for anyone, regardless of the technology that you might be installing. So I've got a handful of different overall architectural diagrams of software and endpoint destinations. And so I want to speak in general terms. So depending on the technology that you're going to be installing, you are likely to need on your production site a media server or a management server, something that manages the software. In some cases, you will need individual agents on each of the servers that you're looking to protect. If that is the case, then you need to factor in some time for rebooting the servers, so making sure that can happen out of hours. And in fact, even if you don't have agents installed on the servers, it's something that we would recommend. And the reason for that is if you haven't performed the reboot of a particular server in a really long time, you can set up your replication software, you can replicate across to your DR site, and then you can power that on really quickly. And it's got those terrific times that you've seen advertised, and it's back up and running in seconds. But that's no good if you've then got to run Windows updates because the server hasn't been rebooted in months and months, and then obviously it's hours before that server is workable and is usable. So that's obviously a factor to consider. So that's your production site. If you're using a disaster recovery service provider, if you're using DR as a service, then you don't have to worry about all of the gubbins on the other side that the service provider is looking after. If you're doing it on your own, then obviously you need to factor in what needs to be installed on the target site, and then that's something similar. So there's a management server that looks after that side, and then there's the configuration of the storage. We've thrown up some examples here of disaster recovery into some of the public cloud services. So depending on particular technologies, whether you are able to use the really low cost object storage or whether you need to use block storage, how that gets configured. And actually for each of the different softwares, it is really quite different. So for instance, to take as an example, if you're looking at Microsoft Azure Site Recovery, there's a very different installation setup on the production site if you're using Hyper-V versus if you're using VMware. Equally, if you're using a particular perhaps Zerto, the method that would be installed on the target site, that would be very different in a VMware environment versus AWS, for instance. So I won't go into too much more detail on this, other than to say let's move on and talk about some of the, I guess, the broad software installation considerations. These are the things that we see come up a lot in the projects that we do. So the first one that tends to be, I guess, a common issue for a lot of folks is if you have clustered databases, if using clustered SQL, for instance. Now, active passive is supported in a lot of cases by various different replication technologies, whereas quite often active isn't. At this point, I think if that's something you do, there's a consideration as to whether you would switch to active passive, or if not, something you can do is simply create a live SQL instance on the DR site, and then add that back into the cluster. Again, there's, I guess, a minor cost implication here, because that isn't a dormant server. It's something that you're running all the time, but it's a good option, and one that we sometimes do. Telephones are, I guess, a key consideration here. They can be problematic for a number of reasons. Firstly, they're often on appliances that can't be replicated. In many cases, SIP trunks won't be supported. SIP trunks aren't something we support from our data centers or from Azure, for instance, at the moment. So, in our opinion, I think there are some better ways to do that. There's some disaster recovery telephone services that you can use, services like Moneypenny, etc. Moving on to USB pass-through, something we see quite a lot. Usually it'll be for a licensing dongle, so that's something that won't be supported. Occasionally it will be for storage, but if that's something that is set up at the moment, something obviously that needs to be worked through on the production side. And the big one here is licensing. So lots of licensing considerations that need to be taken into account. The first is, when you're failing over and you're no longer working on your production site, you're on your disaster recovery site. In most cases, the licensing for that software is included for a short period of time. So commonly that'll be for 30 days. So you're taken care of. You don't need to worry about relicensing software there for your testing, or even short-term invocations. But if you've had a serious invocation that means you need to be running for more than 30 days, then you need to start licensing that software. In the case of Microsoft software, that's something that you could do through, for instance, as a service provider. That's something we do. We can say, right, beyond that point, we'll do that. We've got some supplier contracts. We can look after that. If there's very specific software, perhaps you've got, something through an ISV that you'll need to speak to them directly. And then the other kind of common model is that if you have some software that is based on concurrent users, so remote access, for instance, that one tends to be an easy one to work with, because regardless of where that software is installed, you're only licensing it by the number of users that are on. Although obviously, if you work in an environment where there's only a small amount of remote workers day to day on the production site, and then you're looking to ramp that up in DR, that's something that needs to be thought about. And then the last point, and I mentioned it with telephones, is appliances. So I'm not talking about here a disaster recovery appliance, something like Rubrik, for instance. I'm thinking more about an appliance, something like a NetScaler that you might be running on your production sites. So it's not possible to replicate those machines. So what needs to be done is you need to create a VM on the DR side, copy across all of your config files, and then at the point of invoking, all you need to do at that point is just to license that server. So I guess handful of kind of software considerations that, as I mentioned, these ones tend to kind of be common across all of the different installations that we do. So things to watch out for. Now, bandwidth. So we've been, I guess, running remote backup and disaster recovery services for a really long time. We were doing online backup services in sort of the early 2000s, and back at that point, bandwidth was really relatively small, and performing an initial backup, it would nearly always need to be done physically, a physical data collection taken to the data center and uploaded. Now, connectivity is now broadly good enough that that's a real rarity. As a rule of thumb, we tend to say if you're looking at replicating servers, you want to be looking at around 2 megs per VM that you're replicating. Now, obviously, the real factor here is the rate of change on those servers, not the number of servers. So obviously, take it with a pinch of salt, but it tends to be a good place to start. And then we can use that that calculation to work out how many days it will take to do that initial data transfer. So, if you're looking at, you've got 10 VMs that you want to replicate, 20 megs you need. If it's 100 VMs, you're going to need 200 megs, etc. Now, obviously, when you're thinking about that initial data transfer, again, it's not the number of VMs, it's the total volume of data that you've got. So we actually have a bandwidth calculator on our website. So super simple, just something you can kind of pop in total volumes of data and bandwidth to kind of get an idea of how long that will take. I'll pop the links to that later on. And bandwidth it's one of the things that's really important because it's something that I think if you try to scrimp on, one of the real problems it causes is that it will impact the kind of best recovery point that you might get from it. If you've got less bandwidth, you won't be able to replicate as frequently, and that pushes down your recovery point objective, and it increases the amount of data that potentially you might lose in disaster. So important to have as much as is possible to put in for your site. And then the other issue around bandwidth is it's one of those factors in a project that can sometimes take a really, really long time. So when you're doing that kickoff, I'd say the first thing that you want to be including on that Gantt chart is if you need to upgrade bandwidth, getting that started as soon as possible. Something that can take sort of 3-6 months length of time. So it's the thing that can kind of cause some sort of significant delays. Now, installation and bandwidth sorted. Now we get on to the important bit. Those first two parts are, I think, the thing that I think most people will get right, and then this is the area that I think frustrating. I think a lot of people don't manage to get right, and this is the real difference between just installing some software and really setting up disaster recovery properly. So doing testing shouldn't even be a consideration. It should be absolutely central, but very often it isn't. And I think the reason it isn't is, one, it is time consuming. And two, when you do testing, you will inevitably find things that don't work, and then you need to go through and fix them. And I'll give an example of this of just why it's so important. Really, if you don't test it, I guess it's a little bit of a tautology, but you really don't know if you can actually properly recover. So we did a setup for a business recently, and it was using a particular technology, and we were replicating that into Microsoft Azure. So looking at any of the support matrices that say yes, all of these systems are compatible, everything should work. Okay, great, tick, all working properly. All of the installation works very well. The initial upload worked really quickly. The replication was working really quickly. Everything looks great at this point. And some people, I think, who don't test will find that it feels like it's good. Everything looks really, really, really positive. Actually, you might hear the noise overhead there. We're relatively close to a heliport here in South London, so there's a helicopter coming in. But the problem you have is if you don't do that test, you don't know if something can go wrong. And that was absolutely the case for this customer. So on doing that test recovery, they had a particular setup of how their scratch disks were set up, and it caused an issue. It was workable for a number of servers, but completely unworkable for several others. And as a result, you then need to work through, and there were some changes that need to be made on the production side. There were some considerations as to whether we need to use a different technology to make that replication happen. So really, really important. One of the other factors that you will usually see at this point when you do test recoveries is that IP addresses don't get brought across. Really common if you're doing a cross hypervisor recovery. If you're going from Hyper-V to VMware, or even Hyper-V into Azure, oddly enough. Now for VMware destinations, there's some interesting tricks you can do. You can actually install VMware tools on the Hyper-V environment. It'll be dormant and then will kind of kick into life when you do the recovery. But say absolutely vital. And at this point, what you're testing for, so the very first testing you're doing is, as we mentioned at the top, it's pass-fail recovery testing. Now, there's a distinction in the business continuity community between testing and exercising. And exercise is a big business continuity exercise you'll run, and there's no pass or fail. There will be things to be learned, but you want to remove the stigma of potential failure there. When we're talking about a server recovery, particularly at this stage of the setup, If it absolutely can fail. If that server's not coming up and not working, then it's a fail, and you need to keep working until it's working properly. Now, once you have those servers all coming back and coming alive, the next stage is to do resource matching. Now, the great thing about all of the new disaster recovery technologies and disaster recovery as a service in general is that you no longer need to have an exact match of the same hardware that you have on your production site, which is great. So it means you can have a massive saving. You can replicate across from physical to virtual servers or into Microsoft Azure or AWS. That's all really good. But that being said, even when you match the resources apparently exactly, there is very commonly a disparity in terms of the performance you get because of the difference in the hardware. Now, what you then need to do is test it, see if it's working properly, and if it's not, make some changes. So in some cases, you can perform some auto tuning. You can do this programmatically. You can add some scripts into the software to automatically change the resources on the DR site as they're recovered. If that's not the case, it's something then that you need to work into your manual processes in the DR in your DR runbooks. So at this point, we need to change the resources for this particular machine. And once you've finished doing the functional testing there, you then need to move on to user acceptance testing. And part of user acceptance testing will be some of those performance issues. So you'll be getting a user to check, is this particular system working as it should be? But there's some other really important things that you'll see here. So, and I think actually a lot of the best things that you get out of user acceptance testing is how do you need to communicate with the users? Did they know where they needed to go to log onto those machines? If they didn't, what was the information that you needed to supply to them? Were they then able to find everything as they should? There's a great story that we heard on the Business Continuity podcast, which is a podcast that we run, and we interviewed a chap called Alistair Lee, who is from The Guardian, and one of the things that they do is they spend a lot of time and effort to make sure that the desktops, the look and feel is exactly as it is in their DR side as it is on their production side. And the benefit of that is that their users can just walk into that office and continue to operate. So really important to kind of take on all of that information and then build that into your processes, not only for how you communicate with all your users at the point of disaster, but also what are the things that need to be included in your DR runbooks. So I want to cover a couple of quick parts. We're nearing the end of the session. So when you need to make changes during the setup, I've thrown up back this Gantt chart again. It should be a relatively easy process. So in a perfect world, there wouldn't have been any changes that go on, but in reality, very often it'll take 6 months to put in an increased internet connection, and during that time, there'll be a number of changes that have gone on the production site. But that's relatively easy to manage. You've got a system, you've got people who are working on this all the time. Where things get difficult is when you then make your shift into business as usual. Now, at that point, things can be far more challenging. And the most important thing that we will always suggest is that any changes that are going on in the production side need to be made in the DR side. And the only way that you can really do that is by building DR into your change control processes. So if not, it tends to be very easy to remember the big significant changes, a major shift from VMware to Hyper-V. But for small day-to-day changes, they can feel insignificant, but obviously they're the things that then can cause massive issues when you then come to recover. You need to set up some alerting and reporting. So once you've done your setup, outside the major recoveries, the disaster recovery shouldn't be taking an enormous amount of time. You've done the hard work. But that being said, there's a huge number of sort of day-to-day minor issues. There'll be connection dropouts. There'll be alerts from software to tell you that when SLAs aren't being hit, and they need vigilance. They need some monitoring, and they need you to know when action needs to be taken. Now, again, in a DR service, it's the thing that the service provider will be taking care of. That's exactly what we do. But if it's something you're doing yourself, you need to set up the alerting to make sure that you know when something is becoming significant enough that it's going to cause a real issue to your continuity. And then the final part is I guess a big project in itself. I think we could spend hours just talking about doing the documentation. So writing your run books. Again, another good story from the Business Continuity podcast. We had a continuity manager who worked at a lot of the large investment banks, and the way that he describes writing your documentation is you're not writing it for your A team, you're writing it for your B team. If you've got all of your key people around, the ones who've been working on this project, they don't really need the run books. They know exactly how it all works. But what you want is some documentation that means if they're all away, if half of them are at a conference and some of the others are on holiday, and you've got a lot of people that aren't familiar with the software that you're using and how it all works, everything's in that document for them to be able to recover what needs to be communicated to staff, and as well as kind of the real fine details. So things like if there's let's say if there's an encryption key that needs to be used, or if there's a phone number, so those are the things that are either included or you are told where you need to go to get them to find it. And once you've finished that and you've done all of your documentation, you've then shifted, you've kind of finished that setup, and you're now in business as usual. So you've kind of completed your setup. I see we have run kind of pretty much exactly to time, so I'm afraid we won't have time for the questions. I do see a couple. I promise I will get back to you on those. The resources that I mentioned at the session today were the bandwidth calculator. So got the link here, and we'll send it out shortly, and a link to the podcast. Do take a look, and then any other questions, then obviously always do feel free to respond to those emails when we send out the documents. Thank you again for joining us, and we look forward to seeing you on the next webinar. Thanks all.